All right, welcome to the Standard Fluids Splashcast, where innovation meets application. We're going to talk a little bit more in depth today on this third episode, now that we're kind of getting into a routine around these, and an episode about engineered fluids. So previously we've spoken with Steve Pignato, who will be on the call today, and Kelvin Cabrera. Steve oversees our engineered fluid side of the business, and he partook, I should say, in the previous conversation around PFAS with our technical advisor, Paul Rivers. And we also have Kelvin Cabrera, who was on the episode, recorded episode 2 with Luis Gonzalez and myself, talking about the fire industry applications of things.
Sure.
So really excited to talk to you guys today and do more of a high level overview, I guess, around our engineered fluids, some of the unique applications and some of the big industries that we're hitting on. And then we'll go deeper in some later episodes around things, but really excited to find out some origins around the products, learn a little bit more about some of the applications for things, and find out what Standard Fluids is doing in the market and what we're looking forward to do in the future. So Steve, I'd love to pass it off to you to introduce yourself and pick up the conversation.
All right. Thank you. Thank you
Yeah.
very much, Nolan. Hi, I'm Steve Pignato, Global Director of Engineered Fluids here at Standard Fluids, and had the honor of working at 3M for 33 years and actually seeing the development. Worked in the laboratory at 3M back in the early 90s to the mid 90s, when things were making changes within 3M in the electronic fluids or in the chemicals business at 3M, where for many, many years, decades, 3M was supplying perfluorocarbons, which are great fluids for the applications they were in when they were needed for electronics cooling or electronics testing. They were the best option out there. But they had one issue that they have and had, was their global warming potential was very high, because it was such an inert, fluorinert, such an inert chemistry. It didn't break down in the atmosphere. So the GWP, the global warming potential, was very high, 10,000 plus, depending on the molecule, right? So in the early 90s, late 80s, early 90s, the chemical businesses started to see issues and with the CFCs, right? So chlorofluorocarbons were really getting hit because of the ozone depletion potential. So 3M was selling some of the PFCs into these markets where the Freon 113 or the trichloroethane 111 trichloroethane was being phased out. But then people and the folks at 3M were like, well, this fluid has high global warming potential, so that's going to be an issue. So there was a very concerted effort at 3M, actually the best fluorochemists in the world, honestly, putting out countless molecules, and trying to solve this situation of having a very useful, inert, low toxicity, non-flammable fluid that's used in electronics, but then bring its global warming potential down. And the chemists that did a lot of the work, there was a whole team that did a lot of the work, but Rick Flynn, when I was working in the laboratory, Rick Flynn was making these molecules, and I was a tech aide and I was doing testing on these molecules. And the HFE, the segregated HFEs, which are now standard fluids, SF 7100, 7200, 7300, that molecule turned out to be everything that you would want. Stable in high temperature applications or in boiling applications, very low toxicity, so people can use them even on a desktop, all day long, cleaning and preserving books and stuff like that. So there's so many different applications. So that's really kind of the turning point for the chemical business at 3M. And then having all of the Standard Fluids folks that worked at 3M have all this background and knowledge of these HFE molecules. It's been very helpful for us to launch this company and get these products out to the market, because the decision that 3M made was, it is what it is. They decided to get out of this chemical business for multiple reasons, but this chemistry was really sustainable. And I think the decision to get out of all the chemistry was not the best, but it helped us move out and become Standard Fluids, and then supply these, highly sustainable, environmentally friendly, people friendly, and useful chemicals to the world. So
Yeah,
that's really where
definitely.
HFEs came from.
Yeah. So you touched on, I want to hear a little bit about where you got your start, because you said that you were working in a lab at the time. Where were the products at in their development, or the molecules at when you got your start? Because you've seen these develop a long way. But what year was that, if you even want to
I
talk
don't even.
about how far
It
it
was
is?
1992 or 1993,
Yeah.
or in that realm, because I was a student at the University of Minnesota, getting my chemical engineering degree. My father actually worked at 3M in this same division, so he was, after I did a year or 9 months as a janitor, right? I was a janitor at 3M for 9 months. After I got my first quarter of chemical engineering at University of Minnesota, I could move into the lab as a tech aide. And that's what I did, 1991, 92-ish. And then I was all sorts of testing and stuff on the fluorinert. And then when these fluids were starting to be developed, I mean, honestly, I would have vials and jars of fluid on my desk when I came in from school. And the first things that we did was break down. We'd put it into these power reactors with water, and put it into an oven and cook them for 48 hours, and then measure the fluoride ion generation. It shows you how stable they were, right? And the HFE SF7100 and HFE SF7200 were the first molecules really that I tested in the laboratory, and they were very stable, right?
Yeah.
And then, of course, those molecules go through, years of commercialization and testing and registration and tox testing and whatnot. So, I really got to see the very start of the HFEs. So
It's so cool that you have seen it since its inception, more or less, right? And its development of things, and still being able to I guess get it out there in the market, help find solutions that this can help with, or vice versa. But yeah, that's just so cool. So Kelvin, I'll pass it to you now. When was your first experience with these fluids?
Oh my gosh. Firstly, it's like, I think 125th part of interesting as Steve, it's just so no, I thought my first dip into Novak was back in 2012, that I got called in. I actually trained internally when I was in 3M. I was in charge of telecommunications in the Puerto Rico and Caribbean region, right? As a technical engineer. And I got called into this training back in 2012, and I got called to spend three days in Decatur, Alabama. Then I went to 7 days into Minnesota, into St. Paul, and then 4 days, 3 days more in San Francisco with Pete. I mean, Steve remembers him. So my first dip into the Novak realm was actually with Paul Rivers. I did not know that Paul Rivers was one of the inventors of Novak 30. He just picked me up in his pickup. We started working. I mean, besides Novak 30, got dipped into jet fuel because it was an experiment that we were doing a testing. Everything that could go wrong went wrong in that day, but graciously everything. We made all the corrections, and when the actual final test came out, everything went perfectly. That was the test of the hush house with 30. From there, I went to the 3M labs, and that's where I started. I met the team over there. David Hasselhoff, who was in the lab in those days, and he taught me about all the cleaning fluids. Mostly, given that in my region, the applications were for precision cleaning. I work with great people over there teaching me about vapor degreasing, and this machine does this, and you know, you use the 7100 and the need for this, use the blends for this others, and it was interesting because I mean all the chemistry side, Steve knows it. For us, you know, normal, you know, mortals,
Us
and
lay
yeah,
people, right?
yeah. I mean, it's kind of short of magic when you touch it and it evaporates, or when you get something wet and it does not get damaged, and how to be able to clean parts so quickly and so safely without fire. I mean, it doesn't smell bad. I remember, you know, when I used to work with my dad in his industrial world. I mean, if it doesn't stink or gives you skin rash, it doesn't clean well, right? That was back in the old days. Then you touch, you know, and you work with the Novec, and now the Standard Fluids, blend, and you know, it's odorless, is not non-flammable, non-toxic, safe for the environment, and you know, that was my memory swap out, right? And it actually it turned me into a true believer, because I mean, I used to come from the telecommunications world, so I had to, first of all, learn a lot of technology. Second of all, I learned it from the best people. I mean, those people back in the day, oh my gosh, it was so good, such great minds, as Steve has mentioned. And then being able to tell my story to our customers in my region in Latin America, you know, because I do not come from the background, right? So I had to tell the story in my style, of course, in Espanol, in language, in my language, in my region. But you know, more than that is how do I explain people how this works in a way that it's understandable to them, and also that it's a fun way to work to show it, right? And you know, that's where you start with the demos and you start experimenting here and there, and that you know, that was how I started back in 2012, and formally in 2014, when I started, you know, taking charge of the Latin American market from Mexico all the way to Patagonia. It was a really nice time, and being able to demonstrate customers who wanted to see, you know, from the SARS, you know, from will my electronics get damaged, or plugging something, you know, under the fluid, or being able to clean something very intricate or delicate in an electronic board, or in the medical device, you know, place, something that had really delicate parts, and you had to choose correctly which kind of chemical you would use, which kind of, you know, if it's 71 IPA or is it 7100, and doing those testings. And I mean, it was super interesting, uh, fascinating, technically challenging. And, you know, on the other hand, every switch that we made from either the TCEs or the NPVs or the HFCs, I mean, we were doing changes to be able to do safer work, more environmentally feasible work. So, you know, we were raising the bar. We set up the standard into doing something that was normally done to something great, you know,
Great.
something really elevated. And I mean, that was really exciting. I had a chance once to make a comment to, it was in a meeting that I had with United Nations Environmental Program rep in Panama. I remember that I was talking to him, and I told him, you know, without giving out numbers, you know, financial numbers and stuff, but I told him what, from based on what we have sold in the last 4 years, the CO2 impact offset that we had done using the EPA's calculator for global emissions, and his eyes just went, what? You know, he was just dumbfounded by the impact that we did. And that's the kind of stuff that for me, you know, it makes my day, being able to do those changes.
Yeah.
That's my bit of the story.
Yeah. No, and that I feel like kind of summarizes what you're doing now with the engineered fluid side. I know you and I work closely together on some fire application stuff, especially with the support down in Latin America.
Uh-huh.
I don't know much Spanish, but you've been helping me with some of it. Um,
Yes.
but you now working with Steve on that customer support, sales support, internal management of projects related to the engineered fluids and everything. And again, with both of you, Kelvin, your just genuine passion and interest in these applications and kind of the unique way of solving problems, along with Steve's, Steve, I always say you're just a nerd about this stuff, but you really are. Your like technical expertise and knowledge on this
Yes.
is so it's so impressive. It's overwhelming, but in the most like inspiring way. It's like I want to know more about this and understand it and everything. I don't know if I ever will understand it. Again, going back to how long you've been a part of these products and you've known them from the beginning. Um, I myself, I'm a car nut. I've always loved cars ever since I was a little kid. So I've learned about cars growing all the way up. I didn't like you. Your dad worked in chemistry and science, and you've learned these things growing up ever since. So you
It's so normal to him, right? He just makes
yes,
it. Yeah, I mean, it's just
right.
and he just burbles out some long chemical name, and for us, it's like, what the
I
heck
know.
is that?
I
Yeah.
know. I'm not even going to try to attempt to rename any of the products that he was
Oh
naming
no, no.
before, but I'm sure we'll get a nice transcript of it when this is all said and done, and we can we can review it that way. So I want to kind of talk a little bit about some of the markets that these engineered fluids apply to. One of which that we'll do a deep dive on is the immersion cooling, which is our SF649 product. So if you guys want to talk a little bit about that, maybe back and forth, Steve pick a product, Kelvin pick a product, give us a brief synopsis of the product and maybe the market that it applies to, and some of the unique things that most people don't know about. I didn't know about really any of these when we started Standard Fluids, but it's been fascinating to learn a little bit about it. So, Steve, if you want to
Yeah,
pick
let
one.
me start out because it's really like it's it's um it's nothing new.
Right.
That's number one. And the thing that I'm pretty excited about is you go back to 1969, honestly, to IBM in Poughkeepsie, New York. The team there, I actually got to work with some of them in the 90s. They were all on their way out being retired and stuff like that. But Robert Simons actually took Fluorinert and a IBM chip and boiled the Fluorinert and cooled the chip. So there's a lot more to it, but that's essentially what happened. And then IBM used the fluid through the 70s to test their multi-chip modules. So immersion cooling wasn't anything new because they would do it in, transformers and radars and all sorts of stuff. But for computers and for chips, that's really where it started. And 3M Fluorinert was part of it right from the start. So it's kind of cool in that regard. And then Cray Research in the 80s and 90s, they were using the Freon 113, so a CFC to cool the computers. Total immersion, single phase. They were cooling the computers with Freon, but it had such high solvent power that they were having compatibility problems. So they moved to Fluorinert in like the mid to late 80s. And there was the Cray 2 that used 3M Fluorinert. I might be getting the exact numbers wrong, but Cray used the 3M Fluorinert all the way up until about 1997. And I had been in the lab, went into sales in 1995, and Cray was my first account. Like I'm in St. Paul, Minnesota. They're in Chippewa Falls, Wisconsin. So I made many trips to an hour and a half drive to Chippewa Falls, Wisconsin, to meet with Greg Pouch, who is the main thermal engineer there at the time, and also working with the teams on getting Fluorinert and putting it in the systems. And their largest system had 700 gallons of Fluorinert, which was the Triton T90. And there's great pictures on the internet. It had these, backlit fluid flows like waterfalls, but it was, Fluorinert cooling the computer. So that really stopped in the late 90s when the semiconductor industry they developed CMOS, right? CMOS, complementary metal oxide semiconductor, versus bipolar. The bipolar design of the chip was very hot. And even as they were getting more and more powerful, they were getting too hot to cool. So luckily the architecture changed, and then everyone really could just air cool. So Cray even said to 3M, bye-bye, you know, that business just went away. And then Cray started to air cool their computers. And that lasted all the way up to about 2010. And then that's really where my friend Phil Tuma, we were talking about him earlier, right? And he's all over the internet when you talk about two-phase immersion cooling. And he started work with Dell and Endicott Interconnect, which was part of IBM, and the Mayo Clinic. So Mayo Clinic has a special purpose processor design group, right? And they actually do computer stuff at the Mayo Clinic. So there's papers and work that was done in the very, very beginning with immersion cooling, right? So the main thing that helped two-phase immersion cooling was cryptocurrency or Bitcoin mining, right? Everybody was cooling it, and there was a really interesting company in Hong Kong, and they called themselves Allied Control. And this is all over the internet. You can search Car Wing Lao, and there's a great picture of Car Wing, and the 3M technical rep at the time was George Ip. And there's a picture of him, George Ip, and this gentleman named Alex. They started the company, and they went to the hardware store and bought the very first hardware to put together a two-phase immersion tank. And then in 6 months later, they had a 500 megawatt facility in a high rise in Hong Kong. So it's really neat. You know, the two-phase immersion has been around for a while. It's just been exotic, right? Where, you know, air-cooled data centers have been the way to go for many, many, many years. And today, we're still promoting two-phase immersion cooling. It took a step back because of the 3M decision. There was a lot of work with Microsoft at the time. You know, Microsoft was presenting at OCP, and there's a whole bunch of stuff on the internet about what Microsoft was doing in two-phase immersion cooling. And really, again, once 3M made the decision, December 20th, 2022, everybody took a step back.
D-Day.
Yeah, exactly. So when I started at Standard Fluids, April 1st, 2023, was that about right?
Four.
First 2024. Sorry. I you know, had to kind of get things going again, right? And got the band back together, right? And talked to Phil Tuma, right? And talked to all the companies that we had set up from 2017 to 2022. There were companies that were making tanks and developing two-phase immersion cooling. So you know, Standard Fluids now is promoting that, and that's kind of where we're at with our products. And the products are the SF649 and the SF7100 are the two main products that we're using today. So.
Yeah, and like you said, getting back in with some of those partners and some of those key people that are wanting to test and develop and continue to find those things where things left off. And it's a big part of Standard Fluids is having this team here in the United States and in close contact and easy to work with some of these companies and support them in whatever they may need. So I know that's been a big thing. We've got a long list of customers that we provide fluid to on a pretty regular basis for their testing methods and everything, which has been exciting to learn some of the data and everything that they've been coming up with, which is cool. So Kelvin, do you want to talk about some of the cleaning fluids a little bit?
Well, we are in the phase of reaching out. It's really interesting. People, you know, coming again. I'm going to Peru next week. I mean, if all goes well, and you know, knocking the door on the old people who were. When are you coming back? When are you coming with your, you know, with your stuff? So there's a lot of excitement in the industry of people, you know, waiting for, and we have a lot of catching up to do. As you know, as Steve mentioned previously, you know, D-Day after December 20th, 2022. I mean, things changed. And we were out of the picture for, you know, as soon as that day started, customers started running everywhere and picking anything and literally anything. We've heard, we've seen the data, we know what has been done, and while it's an uphill battle, what we're doing, what we're going up, against stuff, you know, reaching back, bringing back the data, which is what characterizes us. I am saying this, but this is because it's here, and this is the data, right? And coming back and change the story, coming back and setting things straight and setting up, our standard, and likewise for we soon, setting up our partners in the business, like in the States, or like we're doing in Latin America, as we're also working on. And there's a lot of expectation on what what our product is, because there's a lot of um and I mean, the typical word used is misinformation. I would say lack of information. So, it doesn't sound so cliche, but we're in the phase of re-educating people on what we are bringing to the market, which is what we are used to bringing the market, and letting them know, hey, if you want to make the wisest choice, you have to learn, you have to, be as knowledgeable as possible. And that's why we are here, to let you guys know where we are, to teach our customers, how to choose correctly among all the alternatives that are currently in the market. And we're getting there in the pharma business, all the different applications that there are, medical device. We are going to the Costa Rican market, likewise, to reassess the market, reacquaint with our old partners, and do a change in the business. Likewise, for the cooling business, we're doing our contacts here and there in South America, because we had a whole bunch of projects that, unfortunately, after December 2022, things changed. Projects got dropped, and it's easier, as we mentioned in our internal talk, sometimes it's easier to fall back into our usual comfort zone, or into technologies that are in between technologies, because it's more comfortable, right? And after the confusion that was brought into the market, we understand it. It's usual to fall into your comfort zone, but here we are again. Here we are to get do what we did and do what we love to do, which is bring people into the edge of technology, into what's gonna be new, and be ahead of the curve in the technology offerings from the chemical side. Being operational. And go ahead.
You touched on a couple of so you said some of the cleaning applications are for like medical device, pharma. How if there's examples of any of the fluids, and how are they used in a general sense to clean, right? I mean, we've talked about the fire fluid, it's large amounts of the fluid, under compressed gas type of thing. We've talked about immersion cooling, which is a tank, right? That's just more or less static fluid that is submerged. It's flowing and pumped in that regard. But
when I started working with this, I got called into this company that makes filters, right? And how do you test a filter? How do you know if it works? How do you know? And that's where I learned about the bubble test filters, and you pass the fluid through the filter to know how fine the mic, how fine is the filtering level. But whatever you filter, you pass through there in a new filter, you cannot leave any trace of anything, right?
Yeah,
because else you have
it needs to filter, right?
Yeah. So that's where our technology comes in. You can't test the filter; it will fully evaporate. No trace of the agent will be there. And I was just like, when I learned that, I was just like, wow, simple stuff, but it just works, right? Likewise, when you are doing any kind of arthroscopic instrument, or metal, or metals that are used for example, knee replacement, or a pacemaker, that's a really, they used to be bigger. Now they are just this small, but those apparatus are made by machines. They get dirty, and they need to be cleaned with something that cleans it 100, completely well, and it does not leave any trace of the cleanser, right?
Right.
when I mop the floor, it's gonna smell like whatever I put, right? No, this cannot leave anything there.
Right. And that's why the majority of the stuff, I mean, the biggest, one of the bigger, the applications that they would use this is in vapor degreasing. So vapor degreasing, again, you go back to Freon 113 and Dow, trichloroethylene, and it was used in vapor degreasing. And you could take all these knee replacement parts to electronic boards, anything that you would be manufacturing that would need to be clean, there would be these big tanks, and the tanks would have the fluid boiling and creating a vapor, and then the vapor would condense and then going to another sump that would be just totally like clean fluid because you're distilling the fluid always. And the boiling sump would be where all your soils are. So the vapor degreaser is really very well known in many, many industries. And that's where the blends that 3M made, the azeotropes, there was different processes that 3M had that we will be obviously doing here at Standard Fluids as well. But that vapor degreaser design actually is kind of the starting point for data center immersion cooling. Because you could put the fluid into a tank, have it wide open, boiling with condenser coils and parts in and out all day long, and you might lose a quart a month, you know what I mean, if it's done right. I mean, you can do things wrong too, but that was really where Phil Tuma said, wait a minute,
why don't we
just we'll just put the compute, and the compute can boil the fluid, right? So that's really where the cleaning market had its really kind of the start was in the vapor degreasing world. Because we even did co-solvents with Fluorinert with PFCs, which was very clumsy, but it worked well enough. But then when the HFEs were invented, what we found out was that the neat HFEs, like the 7100 and 7200, were actually miscible with some of the solvating agents. So all of a sudden now you were able to mix the fluid in these vapor degreasers, and just the HFE would boil, and the solvating agent would be in the boil zone. It was really cool.
That's very interesting.
That's a deep dive when you go into the vapor degreaser world and the cleaning stuff.
When we did tests and we told customers, hey, your process takes 1 hour and we can do it in 7 minutes. I mean, it's just like, it's impossible. Correct. And I did my share of immersion cooling tests. Oh my gosh! I mean, and they will bring the lab guy to measure everything, and yes, it's a 7 minute full cleansing of your apparatus, right? And with water, with aqueous solutions, it just took forever. Why? Because either there was residue and they had to do another rinse, or the drying stage was like forever, and it was so efficient, lower cost for everything. And I mean, being able to do that kind of changes and turn somebody around from that is just it's the kind of thing that every day it gets you pumped up to let's do another one, right?
And the fluids being so like low toxicity, non-flammable, they worked very well. I in the area that I live, I'm in Bethlehem, Pennsylvania. There was a ball bearing company, like they're maybe 5 minutes down the road from me, and I started them up in probably 1997, and they were struggling with what they were using, and they had an old vapor degreaser, and we just brought out the old vapor degreaser and put the SF72DA into it, right? And I never heard from him again. Like I would see the guy out at a restaurant. I'd say, "Hey, how you doing, Dan?" Everything's working fine, because it was and they'd buy like 5 or 10 gallons a year, but it was just a small vapor degreaser, and it handled all their parts. So it really is neat. Yeah.
I'll tell you a little story. I mean, I was called by this high-end car, company car, really luxury cars, and they had this issue. They had this big issue because there was a turbo diesel engine that they managed, that when there was an oil leak that happened somewhere that got the chip in the turbocharger dirty, and fixing it was horrendously difficult. Why? Because when you were removing the part, all the gunk from the oil and the diesel, and the engine, it will get into the chip, and the chip was really expensive, and it will damage the chip. So while the actual damage of the part A was not so big, the effect of removing it, it just messed it up. And it took long time to get the chip from the manufacturer and to change it and the dismantling. And I remember I went with electronic degreaser, Steve, and I just took, I went, they brought me they took me to the garage, and I took a microfiber towel and the degreaser, and I just sprayed it. All the gunk came out. I mean, just like that, into the microfiber towel. I just cleaned it up, and they removed it, and we just like, wow.
It didn't impact the electronics.
Yeah, and
Yeah.
it did not damage the electronics. And so that's the kind of stuff that you can do with these type of chemicals without being flammable, non-toxic. The vapors are not it's just safe and environmentally safe and really high performance. And that's the kind of thing that I always talk about our product. This triangle of good for the people, good for the environment, and the highest performance level. And that's what we're bringing in standard fluids right now.
Yeah. And there's just so many, and I know Steve said we can go into so many different rabbit holes on some of these things, but there's just so many unique applications. I mean, you talking about degreasing an engine control unit for a car, right? And you also have the cleaning applications for semiconductor and microchip manufacturing. Thinking about I know I've seen videos online. I forget who it is. Maybe it was Microsoft or Intel just released the biggest processing chip that's ever been made, and down to more than microscopic level. It's insane to imagine, but we're talking about spaces that you can't even get anything into yet. These fluids can clean that out and
exactly.
keep them functioning in a way that nothing else can. And it's not something that most people think, oh, well, that needs to be cleaned. Yeah, you look at the dust on your bookshelf, right? And you're like, all right, you dust that off. But how do you clean something that there's almost nothing that can get into those spaces? It's super fascinating. One of the other really cool applications, Steve, that I'll ask you to kind of do again a little bit of an overview of, but is preservation for bookkeeping documents, stuff like that for these fluids. Because I think one of the problem is a very unique problem that most people don't necessarily understand. They look at a book on their bookshelf and say, why are the pages of my book yellowing, right? And how there's some organizations out there that use our products to fix those problems.
Yeah. Oh, well, that's one of our good customers. Their name is Preservation Technologies. They're here in Pennsylvania. It's in Cranberry Township, just north of Pittsburgh. And it's when I joined Standard Fluids, I knew of them, and they were a good customer of 3M's. And how I knew of them was that in the 90s, when I was in the laboratory, I used to send out samples too. It's the salespeople would call and say, hey, can you send a sample of this product to this person or blah, blah, blah. And I remember this application so well because essentially, in the 90s, I sent them a sample of I think it was PF5080 or, the C8 molecule. They would use it to deacidify the pages of books. So in all the libraries and Smithsonian Institute, they sell a product where they use our fluids to it solubilizes magnesium oxide, and then you can dip books and pages and papers and whatever because our fluid doesn't react with anything. And it won't damage the binder of the books and the adhesives and all that stuff. But what it would do, it was deliver that magnesium oxide to inside the pages and deacidify the pages. So it would necessarily stop the pages from deteriorating, right? So that's their business. They also do some other stuff with film cleaning and, the old, movie film preservation. But using our fluids, in that type of application is just really neat. And because of the low toxicity, they're actually spraying this on documents on a desktop, right? They have a product where they, maybe like documents or something that they're trying to preserve. And
it's people physically working over it and around it, right? So
yeah, it shows you. And this has been 25 years that they've been doing this, and there's really, no issues with human interaction or flammability or anything. So it's a really, really, really neat product.
No, it's again, I think the problem identified is such a unique problem. I don't think many people really think about why of the pages of a book made yellow, due to the acid and everything that it absorbs. But then to be able to find products that come together like this, that you can soak essentially a book or documents in it to preserve them in this way is so fascinating. I know from my side with the fire protection, seeing SF1230 apply on a fire, it looks like magic. It doesn't look like how you would imagine a fire is typically put out or anything. And conceptually it sounds made up, right? But it's so cool to see it work. And the same applies for what Preservation Technologies is doing. They are making magic with what they've done. It's super fascinating. I know another thing that that might be an interesting one to talk about. My wife is like a huge true crime person. I feel like so many people are nowadays, which is so funny. But some applications for like forensics, right? And there's some applications for the fluids when it comes to forensics as well, which is cool.
Correct. Yeah, the HFE 7100, again replacing the Freon 113, and that product being phased out really kind of hurt a lot of industries.
What was the ozone depletion potential for?
It was horrible.
Yeah,
it was horrible. Yeah, and there's books and stories about that we won't get into, but and DuPont and all this stuff. We'll stay away from that for now.
Yeah.
But the HFE 7100 does a good job of solubilizing ninhydrin. So it's a protein, an amino acid, whatever it's called, ninhydrin. And if you have fingerprints on pages, on a cardboard or paper or whatever, you couldn't do the traditional stuff of getting off a metal or glass, but you could develop them with the HFE 7100, the standard fluid 7100, and then the ninhydrin would bring that fingerprint out on a piece of paper. So so a lot of the crime labs all over the country would use the 7100 for that.
Again, just like mind-boggling stuff to me. I think it's so cool. And it's fun to be reminded of these things. I know I'm in my fire protection bubble a lot, so talking to you guys is fun to get back into some of these topics, because I know, Steve, the first few conversations we had and the first time you and I met in person, you were going through all these things and my mind was blown. It still is blown today. So we'll kind of start wrapping things up. I want to go through a few kind of lightning round questions, and sure. These can be short, long, however you guys want to answer them. But what do you, from each of you, what are some misconceptions or key things that people need to know about or think about when it comes to engineered fluids? I know that's kind of a big blanket question for a lot of various products, and Steve is thinking on the molecular level right now.
Definitely.
Yeah. Kelvin, I'll go with Kelvin first, then I'll let Steve put together his answer.
Firstly, I would say people think it's hugely expensive, right? And that's an actual misconception, because when one thing that we have to take into consideration is the total cost of the whole application, right? For example, if I use water and soap to clean something with grease, and it takes forever to clean it, one is time. Second, the disposal of the toxic products and the water, and the permits and the cleaning of the water and the reprocessing of the water. But people are so used to use water for cleaning that the water waste and all the paperwork behind it just It just, it's taken as normal. And the $2 bottle for $2, per ounce, whatever, per pound on the bottle, which is so cheap for which is regular soap. Well, yeah, but all that waste and all that damage that's been done and all the time it consumes costs money. So, and I'm really being, oversimplifying stuff. And when you use engineered fluids for precision cleaning, the overall cost of the solution, when made right, is one that's typically highly, it's a better deal. The total cost of ownership is really lower than the aqueous one, while being safer, while generating less waste and such. I had the chance to work
doing a better job, right? I mean,
exactly, plus doing a better job. I had the opportunity to work with that in an electrical manufacturer here in Puerto Rico, and when I got in touch with the engineers to say, well, but your fluid is so costly, and I told him, and I brought the EHS person, and I told her, I remember, what are your costs for all the paperwork that's generated due to the fact that all your residue and dirty and stuff things. I mean, you have to report that, you have to document it, you have to dispose of properly, Yeah. And she mentioned the number at the end. I mean, our solution was 1/4 of the cost of the whole package with the aqueous cheap. So, seemingly economical solution. So one misconception is price versus cost versus actual cost. I would say it.
That's a good distinction to make. Steve, what do you got?
I would say that these are not the PFAS you're looking for.
There you go. There you go.
We already did.
I left that one for you because I know. I mean, because I can talk about that forever, but you're more versed than I am.
And I just did the Jedi mind trick on everyone.
Yes. Yeah. Exactly.
PFAS you're looking for. No. Again, we already did this with Paul Rivers, but ultimately thousands of different molecules that have the signs of being a PFAS, the CF, CF2, CF3 bond. But these fluids have been proven they do not bioaccumulate, they do not partition to water, and they have short atmospheric lifetimes. So it's been something that we discuss a lot. And I think that the world will see that, there are sustainable versions of PFAS that are out there, just like any other chemicals. There's bad hydrocarbons out there too, but we use hydrocarbon every day. So
no, and I think we're, like you talked about, Steve, we talk about PFAS stuff all the time, internal to us, and as well in all the markets that we work in, and it's a point we don't want to talk about all the time, but it is certainly one that's worth considering and reflecting to say, hey, these PFAS is a conversation because of products that we already knew were really bad, right? These ones are a different breed of products that just happen to fall under the different categories. And so it's good to consider those and have a conversation with people and understand them. And that's what we're here to do, right? If anyone has those questions, reach out to us and talk to us, and we're happy to do it. Second question would be, what is, and you can pick a specific fluid, specific industry, whatever, but what are some of the biggest mistakes that companies are making when they're choosing fluids or products?
Oh, choosing a non-certified, non-tested product. Unlike what we do. I mean, we make sure that everything's made to our liking, to our specs, and we actually double test that against, by someone else, not us. And I think, just saying that everything's the same is not the same. It's like saying that a Yugo, remember the Yugo, the cars?
Yeah.
That is small and it's compact and it's the same as the Toyota in quality. Right? It's no, it's not the same, right?
Yeah.
I mean, that's one thing. Yeah, that will be my take. Yeah.
Just because it looks the same and promises maybe to do the same thing doesn't mean that they're made the same or actually are. Once you look beneath the surface and you look at things in its components, that's where you realize where the difference of quality comes in. So
Exactly.
Yep, that's a good one.
Exactly.
What about you, Steve?
For me, I think, especially in the semiconductor industry, choosing products that they do not have the stability that the Fluorinert or the Novec fluids have in the
Gotcha.
applications. So that's really it.
Yeah. That sounds, I mean, the stability being the kind of rate at which it breaks down type of thing.
Yeah, where they at certain temperatures the fluid will break down into acid and create
Gotcha.
havoc in the chillers in the system. So
yeah. Very, very good. And what is one thing that either maybe applies to our products now, or maybe is an application that we're looking at in the future? But what's a market or something that people aren't talking about that we're looking at that maybe some other people should be thinking about?
I don't know. We talk about that though.
In however terms you want to.
A product, might be a high boiling, fluorinated product that has the low GWP that you would need, right?
Yeah, and I know one that is talked a lot about, and certainly something that's considered in all aspects for the fire industry is how do we deal with lithium-ion battery fires, right? And the high heat there and stuff like that. And the current SF1230 is a solution, but as anyone in the fire industry knows, it doesn't. You can't put out a lithium-ion fire. It is kind of its own beast. That's a different challenge, and so something along the same lines, right? A higher boiler that can sustain that heat better is something that.
I mean, we can prevent thermal runaway.
Yes, we can.
So I mean,
but the fire side,
and on the fire side, so like if it does start, the C6 ketone will prevent thermal runaway, but then we're also making C7 ketone, which is a higher boiling point, and it reacts the same. So yes, I mean in that regard, we could certainly make higher boiling ketones, but I think the C7 does a pretty good job of preventing thermal runaway. And if you prevent it, then you won't have the fire, right?
Exactly.
I mean, once it started, forget about it. I think everybody knows that, So, and maybe I don't know. Yeah. Anyway, that's my answer.
What about you, Kelvin? Any interesting things? I know you travel around a lot, especially in Central America, Latin America. Any interesting questions or requests that you've maybe gotten from people that you thought, is there something here that we could do?
I will tell you one thing that I know is severely underprotected, and it's historical assets and media. I mean, when I remember when I heard the fire that happened in Brazil in the museums or Notre Dame here or there. I mean, there's so many places where historical, invaluable assets are not properly protected. Okay, when I heard that once, there's a huge, historical archive that's protected with water. It's like, why? I mean, this product. Our product has been in the market since the 2000, right? 24, 25 years right now. But before that, the HFCs, you could protect it. Why don't you protect high value assets with it, right? We have made studies that our product is the one who yields the less, it's the best one in terms of, protecting environmental media. That's another topic for things, where should you use, where to use it. But, that's one of the things that besides the obvious is data centers, electrical rooms, all technology media, right? But what about our history, and that's one of the things that I think are severely underprotected, and I will say globally, because every time you hear something that's destroyed by fire, so many years old, and historical media or paintings and such, it's just really, really sad.
Yeah. No, I mean, just recently, I live here on the Gulf Coast, and there was a fire in, I believe it was Mississippi, at an old antebellum home, a plantation house. Then there's lots of historical plantation houses, but one of the largest plantation houses, just last week, completely burned down. I haven't looked into it to see and understand what the protection there was, but certainly something that's talked about, and it's very interesting. I actually was just learning that was it Mount Vernon, George Washington's home in Virginia, I believe, right? It has parts of it, and there's currently work being done to protect it with SF-1230 and other kind of clean agent solutions like that, which is very fascinating. So that's a good point to mention, Kelvin. So
thanks.
Yeah. With that, I'm gonna wrap up. I've got a dog that's begging for my attention now. So I appreciate this, though. It's fun to do these. If probably people don't know, we're recording this on a Friday. This is kind of a way that we get to wrap up our week a little bit with some fun work conversation. But we just kind of tell stories and talk a little bit about stuff and get ready for the weekend. So I appreciate you guys' time and everything. And I thought this was a good conversation. We'll definitely do some more in-depth stuff in the future, and you can bring all your notebooks, Steve. Yeah.
Thank you.
So
thank you, Nolan.
Yeah. And for everyone listening, thank you for listening. Stay posted for other videos and podcast episodes that we put out. We'll be doing further technical deep dives. We'll do some more interesting casual conversations, maybe even some live recordings at conferences in the future. But thank you so much for listening. If you have any other questions, go to standardfluids.com, find out any more information about our products, or reach out and get in touch with us. My email is ndmackey@standardfluids.com. Kelvin is KN Cabrera at standardfluids.com. And Steve is SA Pignato, right, Steve, at standardfluids.com. So you can get in touch with any of us, these guys for engineered fluids, me for fire, or any other kind of general questions you may have. So thank you very much, guys. Have a good one.
Thank you.
Have a good one, everybody.